You are listening to The Vocal Technologist. Spoken tech for your ears.
I feel like we need to start every conversation now by just taking a deep breath.
Yeah.
And just acknowledging that the ground beneath our feet, technologically speaking, is shifting faster than sand dunes in a hurricane.
Yeah.
It is exhausting.
It is. It really is. I mean, if you're trying to keep up with every single AI announcement, every code rewrite, and all these massive corporate power plays, you'll just drown.
You will.
And that's kind of what we do here, right? We take all that chaos, that reality, and just compress it. We hand you the core insights so you can be informed, not, overwhelmed.
Absolutely. And our mission today is really focused on this huge essential paradox that's defining this whole era of tech. On one side, you have the lightning-fast emergence of these truly autonomous AI agents, these so-called infinite minds. They can just execute tasks without ever sleeping.
And then on the other side, you get this bizarre, almost low-tech reality check. The completely unexpected ways that these super advanced systems are still creating new technical debt, brand new infrastructure challenges, and some incredibly niche but essential human jobs. It's this tension, right, between limitless automation and the lingering need for human judgment.
So let's just jump right into that agent revolution.
Yeah.
Because 2025 really felt like the appetizer.
Oh, yeah.
And 2026 is, it's shaping up to be the year of agents. We're seeing a fundamental shift in what AI is even for. It's moving way past being a conversational partner.
And becoming a specialized executable task manager. And you can actually see this evolution in these small, subtle ways in the products we use every day. Like, take ChatGPT.
Okay.
If you've used it recently, you might have noticed OpenAI quietly rolled out new formatting blocks, a little mini editor toolbar. It's a subtle change to the UI.
But it's a huge psychological shift for the tool.
Exactly.
It totally shifts the user experience from being a place where you chat to an environment where you are drafting, structuring, and, executing formatted documents. It's a rich text editor, basically.
It's turning into a command center for taking action, not just a suggestion box.
Yeah. And the tools for developers who are building these systems, they are advancing so fast to match that agent-centric reality. Look at Vercel's AI SDK 6.
Right. Developers are now getting these orchestration features, things like built-in agents, tool execution approval, and full support for something called multi-chain prompting, or MCP.
Okay, hold on. For listeners who aren't, deep in the development roadmap, what does orchestration even mean in practice? What does that full MCP support let you do that a standard prompt couldn't?
It means we've moved beyond just one single question and one single answer. MCP is essentially building a complex pipeline. One agent's output automatically becomes the input for another agent.
Wow.
Which might then call an external tool like an image editor or a financial calculator. It's systems thinking, but translated into software. It lets the AI manage these super complex multi-step workflows all by itself.
And this is where the philosophical implication really hits.
Yeah.
And frankly, this is the most troubling part for a lot of people. This infinite minds concept. These systems are perfect at delegating and just executing all the busy work. They never need a coffee break.
Exactly. And when that execution layer, the simple, repetitive, or highly structured work, when that becomes nearly free and instant, the biggest consequence is felt in entry-level and early career roles.
Right. Those positions have always relied on learning by doing those simple execution tasks.
And as that execution gets cheaper and that layer gets thinner, those first couple rungs on the ladder are being disproportionately affected.
We're seeing big business wrestle with this directly. Amazon is a great example. They're facing what you could call the ultimate leader's dilemma.
Yeah.
Their whole platform thrives on data product reviews, buying habits. So should they fight the new AI shopping bots that are constantly scraping that precious data, or should they just join them?
They can't seem to make up their mind. On one hand, they're investing heavily in protecting data like product reviews, which are these crucial assets that their competitors want to train their own models on.
Of course.
But on the other hand, they're actively testing their own agents that can buy products from other competitor sites directly inside the Amazon app.
That is a fascinating hedge. It's like saying, we hate that you're scraping us, so we're going to scrape you back, but, with better AI.
It shows that even a company at Amazon's scale knows the agent revolution means you have to move beyond your own garden walls. And those agents, whether they're fighting or joining, they need a stable, secure, performant foundation to run on.
And that brings us to infrastructure. This is where the conversation turns to massive, massive code debt.
Here's where it gets really interesting.
Yeah. Microsoft, a company whose entire history is built on C and C++ code, has announced this ambitious long-term plan to replace its entire C and C++ code base with Rust.
We're talking potentially by 2030. This is more than just a language preference.
Oh, it's way more.
It's a commitment to security at the foundational level. C and C++ have these memory safety issues that cause a huge percentage of critical software vulnerabilities. Rust just eliminates those classes of bugs. The system becomes inherently more secure.
But the scale of that undertaking is almost unimaginable. I mean, millions upon millions of lines of legacy code at Microsoft. How do you actually achieve that? You can't just hire 1,000 people to translate it line by line.
You can't. And they're solving the translation problem with the very technology they're trying to secure. They're actively hiring engineers right now, paying incredibly high salaries like between $139,900 and $274,700.
Wow.
Is specifically to build AI and algorithms designed to help automatically rewrite and audit these colossal code bases.
So it's AI fixing the code that runs the AI.
Exactly.
That is structural upheaval, and if the code is changing, the hardware running it has to change too. We're already hitting a local AI bottleneck.
We really are.
Because the average laptop is it's underpowered for running large language models locally with any real speed.
Yeah, if you're running a serious LLM on your machine, you realize really quickly you need vast amounts of memory and rapid parallel processing. For personal computers to handle this, two major architectural shifts are absolutely necessary.
Okay, what are those shifts?
First, we need a powerful neural processing unit, an NPU, to live permanently right alongside the main CPU. The CPU handles general tasks, but the NPU is purpose-built to accelerate all the repetitive math that AI tasks require.
So the NPU is kind of like a specialized high-speed calculator just for AI.
That's a perfect way to put it. The second necessary shift is a unified memory architecture.
Right.
So think of it this way. Right now, your computer has separate desks, one for the CPU, one for the GPU or NPU. They have to constantly shuttle data back and forth, which takes time.
Okay.
Unified memory is like one massive shared workspace where all the components can access the model data instantly without copying it. That's essential for these models that are often too large to fit in specialized, segregated chip memory.
That's a great analogy.
And if you're really interested in the nuts and bolts of this stuff, you might want to tune into The Vocal Technologist later this month. We're doing a much deeper look at chip architecture.
Perfect. And speaking of specialized architecture, even the compute king, NVIDIA, is adapting to this new future. They recently signed a strategic licensing deal with Grok for Grok's AI inferencing technology.
This really shows the market reacting to a key distinction in AI workload: training versus inference.
Right.
NVIDIA GPUs, they dominate the training stage, building the model, but Grok is winning at the inference stage, which is deploying the model and having it actually generate text or images for you.
And why is Grok's chip, the LPU, better at inference?
It's custom built for it. Their language processing unit, or LPU, is designed to be extremely fast and use less power for generating content once the model is already trained.
So faster deployment, better efficiency.
Exactly, for the applications that are actually generating outputs for you. This adaptation by NVIDIA proves that the future of computing isn't just more GPU power. It's highly specialized compute for every single stage of the AI lifecycle.
And tying all of this high-speed specialized compute together is the global foundation.
Yeah.
And Starlink is a phenomenal story here.
Oh, for sure.
They recently passed 9 million active customers globally, and they're adding over 20,000 new users every single day.
That kind of scale, covering over 155 countries, signals this massive, accelerating demand for broadband access in underserved regions. This growth is essential plumbing for the global economy and for distributing those agentic AI services we were just talking about.
And naturally, I mean, that kind of exponential growth continues to fuel some very serious speculation around a potential IPO, maybe as soon as next year.
You'd have to think so.
Okay, let's pivot to some specific nuggets for the programming-minded listeners and maybe some user experience upgrades. Starting with web dev, we have the new URL pattern API.
This is a great quality of life upgrade for developers who have to manage complex routing. The URL pattern API defines a standard syntax for pattern matchers, and it leverages the established path to regex library.
So instead of using these messy manual string operations to figure out what URL a user is on, what does this API give them?
It gives them precision and simplicity. It lets developers create much more robust and readable pattern matchers, and critically, it lets them easily extract specific named parts of the matched URL, like a user ID or a product slug using capturing groups. It just makes complex routing so much cleaner.
Makes sense. And on the language front, the release of Ruby 4.0.0 is significant. We've got two key features there, RubyBox and ZJIT.
Right. RubyBox is primarily about isolation. It provides containers for definitions loaded inside the box, which helps manage dependencies and prevent conflicts in complex applications. ZJIT, the new just-in-time compiler, that's focused squarely on performance.
How does ZJIT compare to previous speed improvements?
Well, it's a major step forward. It immediately outpaces the traditional Ruby interpreter. However, the existing faster JIT compiler, YJIT, is still the benchmark to beat.
So it's not the fastest yet.
Not yet. But the inclusion of ZJIT just shows this continuous, aggressive push within the Ruby core team to optimize execution speed and stay competitive.
Okay, shifting to user experience. Google finally rolled out a highly requested feature for Gmail, the option to change your address. You can get a new one with an altered username up to 3 times.
Yes, no more sign-in names referencing your favorite band from 2004 haunting your professional life.
Exactly. That is a relief for so many people whose online identities have matured a little faster than their first email address.
For sure, but you have to note the restrictions. They're being extremely cautious about identity management here.
I noticed that. What are the crucial limitations?
So even after you change it, the original email still works for sign-in and receiving email, which is good for continuity.
Yeah.
More importantly, they impose a strict 12-month restriction between each change or deletion request.
So you only get 3 changes and you have to wait a full year between each one.
A full year. It's an identity security measure just designed to prevent rapid, high-frequency misuse.
Right. Okay, let's circle all the way back to that initial paradox.
Mm-hmm.
We have talked about infinite minds, AI rewriting code bases, trillion-dollar hardware shifts.
Mm-hmm.
Yet, we still haven't solved some basic physical reality problems, which brings us to the Waymo robotaxis.
The irony here is just it perfectly illustrates the gap between high-level AI cognition and physical dexterity in the messy real world.
I love this story.
So what is the most common specific low-tech failure point for a self-driving Waymo vehicle?
They get completely stranded if a human doesn't close the door behind them at the end of a ride.
It's magnificent in its absurdity, isn't it? The AI can navigate complex city traffic, predict pedestrian behavior, choose the optimal route.
But it can't tell if a simple physical latch is closed.
Nope. And because relying on customers or, random passersby to be conscientious is totally unreliable, Waymo has had to create a whole new layer of human work.
So what does that layer even look like?
They summon human help through an app called Honk. They pay human workers $20 or more, sometimes for just a few seconds of work, to rescue the robotaxi by doing nothing more than physically closing the door.
That is a brand new, hyper-niche, physical micro job created by advanced automation.
It is.
That failure point, having to hire a person just to close a door, perfectly illustrates the fragility of relying on perfect real-world execution. We even saw this fragility get amplified during a recent San Francisco power outage.
Oh, that was a mess. That power outage caused citywide gridlock, and the automated vehicles just did not handle the unstructured chaos well. Tow truck companies were called out to retrieve dozens of stranded Waymo vehicles.
The infinite mind needs a human to handle the simple physical reality of a door latch.
Or, more broadly, the failure of the power grid itself.
That human necessity brings us up to the high-stakes capital flows. While we're all discussing engineers and robots, the media moguls are making these massive power moves.
Yeah.
Larry and David Ellison, after buying Paramount, are now targeting Warner Bros. Discovery with a massive $108 billion hostile bid.
This is such an aggressive move. It reflects immense capital confidence. I mean, Larry Ellison personally guaranteed $40.4 billion of the equity financing. That's a huge personal commitment.
And their tactics were extremely forceful.
They were. They sent a letter to the WBD board expressing serious concerns about the fairness of the sale process itself.
And what was the immediate fallout from that aggressive tactic?
It completely surprised the WBD leadership, and crucially, it created enough operational uncertainty that it gave Netflix this unexpected opening to move in and potentially secure a position in the deal.
Just shifting the dynamics of the entire media landscape overnight.
Completely.
Okay, finally, let's just touch on 2 futuristic fields. First, scientific breakthroughs. Researchers are working on foundational models for virtual cells, to model diseases and treatments, conceptually similar to AlphaFold, right?
Right, which revolutionized protein folding. But the primary challenge for success here, they believe, isn't the AI modeling itself. It's the data.
It's always the data.
It's always the data. Creating these virtual cells hinges on creating proprietary data sets that can explicitly identify, isolate, and then mathematically subtract confounding factors. If the model can't distinguish between the signal and the noise in the cell, it's useless.
And a quick update from Mars. The Perseverance rover is still working diligently, filling sample tubes nearly 5 years after it arrived.
But the Earth logistics are failing to keep pace.
That's the thing.
Yeah, the rover is in good condition, it's still doing its job, but NASA has officially delayed the mission to retrieve those samples. It was planned for as soon as 2026, but the sheer complexity and cost of the logistics have pushed that timeline way back, probably into the 2030s.
So progress on Mars is now waiting on budget and bureaucracy back here on Earth.
Pretty much.
So what does this all mean? We've covered everything from AI-driven code rewrites to humans closing robot doors. The landscape seems pretty clear. AI agents are swallowing up standardized execution tasks, and that's forcing a monumental, multi-trillion-dollar overhaul of code and hardware infrastructure.
Yet every single step of that automation simultaneously creates these new, essential, and often really low-tech roles for humans. Whether that's closing a door on a stranded robotaxi or guiding the AI that's rewriting an entire company's code base.
So automation eliminates the simple execution job, but it highlights the complex human requirement.
Exactly.
Which leads us to our final thought. If the primary contribution of humans shifts away from simple execution and predictable processing and instead focuses intensely on judgment, problem definition, and navigating ambiguity, the messy, high-token, exploratory work that AI systems still really struggle to master.
Yeah.
What new unquantifiable metrics are we even going to use to measure impact and value in this new knowledge economy?
That is the defining question for every worker right now. Until next time.
Spoken Tech for your ears.